Okay, guys, here's the benchmark. So a college student completes some courses worth 3 credits and some worth 4 credits. Okay, so this is going to be like 3x. This is 4y. Student earned that many credits completing 18 courses. Okay, you see how this is credits, credits, and credits? So we're going to go with 3x plus 4y is equal to 59. 18 courses, so they're courses, there's 2 different courses. This is x courses, this is y courses, equals 18 courses together. So when I get this, I'm going to get a system, a linear system, right? I'm going to go out here and do menu 413, no, menu 32. Go here, I'm going to go to menu, calculator, menu, what is it called? Menu, algebra, solve 2 equations. Shoot. I think it's 3x plus 4y equals 59. 59, 18, 3x plus 1, 59. 59, and then this x plus y equals 18 courses. 13 and 5. I'm going to go with 13 and 5. Okay. I'm going to tell you this. I'm going to say that's my answer. I'll check right now, but I'll try to check. See, that one came first. That's going to be my x. And that came second. That's my y. And then asking for the 3 credits. So your x credits. So I would go with that. Hold on real quick. Okay, so let me go back over here. So in regard to this one, we got 13 to be x and 5 to be y. So look, if you add them both up, they do give you 19 or 18. Now we'll put them in here. We're going to go 3 times 13 plus 4 times 5 equals 59. Let's see if this works. 13, 39 plus 20 equals 59. Okay. So in the case you're trying to like, what? How did we get that? Because of my logic. X comes first and y comes second. If you get these numbers and you switch them around, you'd have what? 3 times 5, right? Plus 4 times 13. Is that equal to 59? They do add up here on what I do. Oh wait, they do add up right here. But I'm sorry, what's going on here? This is giving 15 plus, what is that? 52? Not even close. Okay? So that doesn't work. Just saying. How do you know it's that order? Because of the way they gave it to me. Moving on. Reference material, guys. You see this real quick? You see all this stuff right here? You've got reference material up here. It's right here, written out for you. Okay. All this stuff. When it's like this, you multiply. You got it? When they're next to each other, you add. So I come down here. So I'm going to work on this one quick. There's 2 kind of questions here. You see this one's the first one, and then you got to work on both of them together. So we're going to do that one. We're going to go with x in the 7 times 3. Right? That becomes x to the 21st. Then, that's this part right here. But then I also have that times x to the 22nd times x to the 22nd. So when they're next to each other, you add them up. So I'm going to go x now 22 plus 21 gives me x to the 43. Going once, going twice. Are you lost there? Whatever. Okay, so the company advertises on the website. The worker tracks the number of visits to a website and then the number of clicks on the advertisement. The table shows the data for the several days. The linear. Ooh, once I see linear, I want you to read the question. Once I see linear, I know what to do. This is x. This is y. X is people. Number of visits. Number of clicks. This is people, okay? Right here. Visits. So all I'm going to do is linear, guys. I'm going to put these things in here real quick. You see list and spreadsheets, guys. Menu 413. Okay, 153 and 629. 153 and 629. I'll turn this on. New document. No. 153. Did I do it right? 153, 629. Over here, I'm going to have 14 and 38. I'm going to go ahead and menu 413. I'm going to go to B, control this, enter, enter. Then I'm going to add a graph. I'm going to go to, so you can see the graph. I guess I'll do it here. I'm going to go control document, add a graph. I'm going to press up for my line. There it is. And then I'm going to go to menu. I'm going to go to trace, graph trace, 1500, because that's what they're asking. About 82-ish. Let me see. Hopefully we got it right. What did I do? All right. 83. Actually, best prediction, guess what I should have done? The thing that said linear, when I said linear over here, I went ahead and I just used it. I really should use them all. I really should use them all. Let me see. I really should use them all. So yeah, let me not be lazy and just do that better. 471, 30. 471, 30. And everything would change. Everything would change when it 471. So you can't do it. So don't worry, I'm going to still do it. And it's going to be changing. If I go over here, it's already going to change it a little bit, okay? Nine 14. What do you got? 7. The current numbers, they change here when I add more information. 307. I'll go back to that page. It's still about the same, guys. So you know what? I'm going to stay there. About 83. About 83. Okay, it's not going crazy off to one of the other ones, so I'm going to stay with that one. Let's try this next one. Which one shows, this is a joke. Remember, for it to be a function, x's do not repeat. Not a function. This is like way, yeah, that's like way bad. This one is a function right here. X's do not repeat. You see, I'm not even looking at this, guys. I really don't even care about this. I don't care about this. I don't care about this. I don't even care about that. I'm going to the top. Not. X's do not repeat. Function. Let's just read this and go through it slowly. Grill at a barbecue restaurant will be used to cook sausage links that are 2 pounds each and brisket that are 6 pounds each. Okay, I can see that. 2 pounds. I'm gonna say that one goes first. So 2 eggs. Okay. I'll look on X number of sausage links and Y number of briskets. Cook X. Just FYI, guys. Math's pretty uniform, pretty cool. First thing is X. Second thing, right? So they want to go ahead. No more than 120 pounds. So this is 120. They want no more. They want that to be like the max. You got it? Can you cook less? You can cook less. Make sense? So this is what you're cooking. This is what you're cooking. They want 120 to be the biggest number. So they want this. They want this to be bigger. This has to be smaller, basically. No more than. Can they be equal to it? It's not saying you can't cook equal to it, so we wouldn't say it can be equal to it. They don't want it to be more than, but they want it to be, it's okay to be equal to it. So I'm going to say that one, and that one. And then this, and this. 2x, 2y. Wrong here. I'm going to go with that one. Hold on. Okay. The total distance in centimeters to a robot moves varies directly with the time in seconds. The toy robot moves the total distance this much and that much. So basically saying they go together, guys. It's really easy. I don't know how you want to set this one up. You can set it up several ways. This goes back to proportionalities, okay? So 264. And this one goes centimeters to 11 seconds. That's going to be equal to total distance of 408 centimeters over seconds over x here, or s. Cross multiply, divide, whatever you want to do. You can end solve it, whatever you want to do. Do you know how to end solve this? I should go to, I'll put x because I couldn't write my s nice. And just work on it there. You okay? So we're going to go here. I'm going to show you end solve, just so you don't forget end solve. Menu, new calculator. Do not save anything from before, just because. And we go to menu, 3, 1, control division sign, set up this fraction thing, and then make it equal to this other fraction thing. Okay. What numbers did I put? 64 over 11. 264 over 11. This one over here is 408. 408 over, you can go S, or I'll go X. I'm going to go here. And 17. Now, if you don't like that one, guys, you can also do this. Where is it? Right here. You can cross multiply. 408 times 11, all of it divided by the ball, 264. Here's your answer. Okay, next one over here. Okay, a college student has 2 different jobs. Her combined work schedule consists of no more than 48 hours. Okay, so a college student has 2 different jobs. So I guess job 1, job 2, her combined work schedule consists of no more than 48 hours in 1 week. So what you want is you want to be able to add them up, and they can't go over 48. Okay, I will tell you this much: this line looks pretty consistent. If that makes sense. You see, okay, and this one does too, right? But this is the thing: you want to be able to work on both, and where they both don't add up over 48. Right? Get this point? Anything in the gray is a solution. You should know that already. Anything in the gray is a solution. So if any of these gray things include more than 48, look at this. This one has 54 automatically out. This is already included in the 54 out. This is the same thing already. This is the only one that couldn't be logically where you could add up anything in here, x and y values, and they give you less than or equal to 48. Cool. Does that make sense? Let me pick this point right here, guys, way over here. This is 54 hours in one job and then 6 hours in another job. How is that going to add up to be less than 48? Doesn't even make sense. So all of these that have big numbers like that are out. That's choice. Okay, this is this one. What is the equation in slope and intercept form? So these are in slope and intercept form. The line that passes through the point, this one, and parallel. For it to be parallel, it has to have the same slope. So you want the same slope of 1.2. This one's out, that one's out. And going through that point. Okay, so I can't tell you what to do on this one. This is like several ways. Okay, so you can understand what algebra is always asking. Does that x and that y value belong to that line? Does it belong to this one? several ways. I'll show you two different ways of doing it, okay? So this one is the point, and that point is this asking, does that point belong to that line? So you can come here to the side and plug it in there. We're going to have, this is my y, this is my x. So for this one here, it has 0 is equal to 1.2 times 5 minus 6. So 0 is equal to 1.2 times 5, which is 1 whole 5 and a 0.2. Well, it gives me 6 minus 6. Slash, isn't that 0 equal to 0? So I'm going to say that's my answer. This one over here, let's try it. Well, this one now. So we're going to plug in the same values here. We're going to say, well, 0 is that equal to 1.2 times 5 plus 5. So this one's 0. This one right here is 1.5 times 5, or 1.2 times 5, which is 6 plus 5. Are those two things equal? No. That's one way. I think that's really fast, really easy. This is another way of doing it. I can't tell you how to do it. There's several ways. I say I always go to the calculator. I just think the calculator is super sweet. Okay? Somebody uses a calculator here. Oh, where is my calculator? Should have closed the meeting. Shut up. That is so crazy.
Yeah.
So say turn on the calculator and then graph it 1.2 x. You see how it's in y equals? I'm going to go plus 3.8. I'm doing my video for the next period. So now let's graph the other ones right here. And now this one's parallel. I'm going to go right here and press tab and then graph the other one at 1.2 and then go x minus 6. And then now what I'm saying is just see if it goes to that one, 5, 0. And see, does it go to 1, 2, 3, 4, 5, 0? It goes to it. Now you see they're parallel? Answer. So you can graph them, or you can just do the work I did. Sky's the limit how you want to approach it. The table shows the amount of pet food in cups remain in an automatic feeder as a function of the number of meals the feeder has dispensed. Okay. Looking at these answer choices, looking at the table, menu 4 and 3, easy. So I'm going to move this down this way. Go to the calculator. So turn it on. New document. No, when this is spreadsheets. I'm just going to put the 1, 3. And over here, 21, 15. Menu 4, 1, 3. B. Control this thing, enter, enter, and there it is. Now, the equation is right there. Let me move this up over. So this is the equation right here. And we're going to go y equals to mx plus b. M is 3, negative 3. Negative 3x plus 24. There it is. This is a joke. Turn the calculator, go here. Now, we're going to go to calculator. We're going to go to here, menu, 3, 1. We're going to go to 3x minus 5y equals 22. Menu 3, 2, and both. Now we're going to go here 3x minus 5y equals 22. And the y equals a negative 5x plus 32. Next question's asking x. 13 halves. 13 halves. Oh, I know it's positive. Not that one. What's the y-intercept of this? Remember, this is like your y. Y equals 29.5, 29 times 5.2 to the x. So we're just going to graph that. Now, sky's the limit. How you want to do this one? I don't know what to tell you. Seriously. I'll show you two different ways, right? Show you the easiest way. I think for you guys, I always tell you that graph it, right? So we're going to go 29, and then parentheses 5.2. We're going to raise that to x. There it is. Okay, where does it cross the y-axis? So I want to just go here, menu, trace, graph trace, and go to the right. There's my y-intercept, 29. Now, I'll tell you this much. This is what I was saying. That's the fastest, easiest way. This one's faster and easier. What do you know if you're on the x-intercept, on the y-intercept? What do you know if you're on the y-intercept? That x equal to 0. So you have 29 times 5.2 to the 0. You should know anything to the 0, guys, is 1. So you have 29 times 1. So it's just 29. Both easy. Okay, I want to stop there if you don't mind.